Hey everyone, welcome to another Open Cluster Management Community Meetings. Today is August 11, 2022. We're excited to have the Red Hat Advanced Cluster Management, the search team, here to present us with the search API. We're hopeful that this component can be useful for the Open Cluster Management community, and we're looking for some feedback. So without any delay, George, please take it away. Thank you.
That'll be me. This is Xavier. Good morning, good evening, good afternoon, wherever you are. Today we'll be introducing search in the context of Open Cluster Management. Okay, this forum does not require any introduction for OCM or Open Cluster Management. Let's directly get started and jump into what is search and why we need it. Let's imagine an organization, Acme. Okay, so this organization has got multiple Kubernetes clusters, and they have OCM or Open Cluster Management to manage all these Kubernetes clusters. How does this application look, right? So say, for example, they had Acme service, which has got so many workloads. For example, they have some UI components, they have some API components, they have some database components, and all these components happens to be running in different that's being managed by the OCM component, right? So say the UI is in cluster A, the API is in cluster B, and so on and so forth. The database is in cluster C. So now this is a setup, right? So for them to successfully run their service, Acme service, they need to ensure that all the managed clusters are running fine, and also all the workloads are running fine in those managed clusters, right? So everything works fine until a day one of their SREs get a notification that their Acme service is not serviceable anymore, all right? Obviously, these SREs have to go find out what's wrong with their service. Now they have multiple Kubernetes clusters in front of them. They got to go log into different Kubernetes clusters, find out what are the related resources that their application requires, and then find out their statuses, right? If they're all running fine or not. This is a daunting task. I'm just giving an example of 3 clusters. What if they have application workload spread across tens of hundreds of clusters, right? So it'll be nearly impossible for an SRE to come in and easily debug and easily find the problem that caused the outage for them, right? So this is a space that search comes in. So we introduce search. Search is is a set of APIs for OCM users so that the users are able to easily find, access, and edit resources from their managed clusters. Okay, so once you find your possible resources that are looking for from an easy accessible place, it's much more easier for SRE to go nail down their problem that they have at their hand, right? Then also, once you find a resource, the search also gives you leads by giving you a list of resources that are related or that interact with that specific resource. So you have an idea where one resource is related to another resource, so they can go see if there is anything wrong with that resource. So that's search in a nutshell. So I just gave an example where presented a problem where the SREs are having trouble. The service is out, and they need to go debug the problem across all their managed clusters. So with search, how will we solve the problem? We'll have a small demo of search, how search is going to solve the problem. I'll turn to Jorge, who will demo our search APIs.
Yeah. So I will show search in action. Like when debugging the problem, you have, like without search, you would have to know the login to each of the clusters and have different contexts, go into the cluster and search, do your CLI commands to see your resources. But not like having search, having all the data in a central place makes that really easy. So I'm going to show, focusing on the API. So I'm going to show how we would search for, I'll start with searching for pods in my cluster. I have like a simple setup with just 2 managed clusters. So I can run this query, APIs GraphQL, So we run the query, we want to see the count of the search result, we want to see the actual items. And this will give the input. Now in this scenario, I'm searching for the kind pod, and I'm gonna limit my items to 100. So when I post this, when I see that it comes back, there's 417 pods across my setup. I'll only see the first 100 items because that's what I requested. And from here, I can see that I'm getting, let's search quickly for cluster. So we can see that we're getting things from all the different clusters. I just skipped it again. So I see most things come from local cluster, but I see things coming from my cluster demo B, and there will be some other things coming from demo B. So I see that there's pods coming from all my clusters. So like I said, there's 400 pods that might not be too useful. So we can go and add more filters. Like in the scenario that we're looking, we want to see pods that are problematic to us. So we can start adding some filters. First thing that we can search for is pods that have been restarting maybe more than 10 times. That would be some indication that there's problems on that. We could add labels. We could search for many other conditions. Just doing a quick overview of what's possible. So when I run this query, just limit the pods to the pods that have restarts. Again, now I get only 19 pods. That's something that we can start debugging. Again, I can see that there's pods coming from all my demo clusters and the local cluster as well. So once I identify the resources I want to focus on, let's say these 19 pods that are restarting, I can start using the other feature that Search brings in. It's related resources. So we can start investigating what things are related to those pods. And so we can create a hypothesis of why they're failing. So in this other query, I'm still searching for the pods that have restarts, but now I'm focusing more on the things that are related. So I can look for related deployments, config maps, and secrets are the three that I'm going to show in the example, but we can search for many other things like the node where the pod is deployed, or other things that relate to it. So when I run this query, going back quickly to show the query. So I still want to see the count of my search query, and then I want to focus on related items. So this is what I'm getting back here. So now I start seeing related secrets, and I get all these secrets that are related to those pods. And now I can start going into those secrets and maybe figure out that something is not configured right. And this is where our future comes in. Like we also want to be able to see it, like these config maps change in the last hour. So that will help us on our debugging journey. Like after I find the things that are failing, get the things that are related to it, and then I can figure out something changed around the time that we started experiencing problems in our service. So that would be a future enhancement that we're planning for. Like we want to keep a history and be able to search on those conditions as well. So with this data and the search just have the index, we can use other features of Open Cluster Management to now go and retrieve the YAML on the managed cluster, go retrieve logs, go and change things on the managed clusters. So all that can come together and be a tool where from one place we can fix the problem in all the managed clusters. So that was the demo of Search in Action. I will go back to the architecture. Xavier, you want to take it back from here?
Yep. Thank you, Jorge. Yeah.
Just want to have a chance. Any questions so far? Right, we'll say it.
All right, so we are saying the architecture diagram, the top big box represents our components that we laid on our hub cluster in OCM, and the bottom small rectangle boxes, they represent the managed clusters in the components that we put in managed clusters, right? So all the boxes that are in red, they are a process or a pod. You can imagine that a pod is running. That's where you also want to contribute your code to. So the flow is like this, right? The flow is like the search collector, the collector that runs in the managed clusters, uses Kube APIs and collects resources, say their names, their properties. And then they periodically sends the data to indexer. So indexer has got a REST API. This exposes a REST API, so the collector can push data to the indexer. We also have a collector that runs in the hub cluster so that we can collect the data from the hub cluster and then push it to the indexer. As soon as the indexer gets the data, it writes to one of the data stores, right? The boxes on the rightmost, on the top big box, they represent a process of client. You could have different kinds of clients that can make use of the search API. Jorge just demonstrated how the search API works and everything. So he just had a view of that. That's a GraphQL-based API that he just demoed. The clients can make use of that API and then make the search, right? And the search API gets the data from the database. The search API also relies on the RBAC for authorization, so that when we return results for a specific user, he's only able to see the resource that he has got view access to. Right, so we don't want to send all the data across all managed clusters to any user, right? We want to be careful enough to ensure that the user is authorized to see the results that we return, right? So that's the flow in general and how things work. We also have plans to include other kinds of resources, not just Kubernetes resources when we collect data. So that's in our future plan. I just want to give a high-level rundown on how the process works here. Any questions on this so far, on the architecture? So questions. So yeah, we invite folks to download and install. Our install scripts are there in the search operator repo that you see there. There are instructions on how you can easily download the operator and then run your own version of search in your cluster, in your open cluster management clusters. So give it a try, give us feedback. All feedback is welcome.
So Xavier, to summarize, I guess, what you're saying is that, of course, this code is right now in the advanced cluster management. We are proposing that if allowed, we will push it to open cluster management. But as you said, they can be downloaded, they can be compiled, they can be run today. And today, we are aggregating kube resources across the fleet. We are also, as Jorge demoed, right? You can get pod details from any cluster. You can find out on which cluster it's running, what's the status of the pod. You can even look at the logs, etc. And then the next level deep item is we build relationships. So we find out what things are connected to that pod, or more importantly, what things are connected. For example, if it's an operator, what are the things that the operator is creating, etc. And then finally, where we intend to go is be able to come right to the point to tell what's changed. Now, Jorge demonstrated that manually, that you can infer, but we want to avoid those steps so that you can get to it directly, right? And the other thing, Xavier, while you were giving that example, it struck me that, well, I mean, it's true, we use this internally. I mean, the flow that Xavier said, we use this all the time. We also have monitoring going on. We also have alerts coming in. We also have Grafana dashboards to look at the data. But we all know that the Grafana dashboards give you only so much. There is a time where you really need to find out, drill down to the deployment of the service, to the Kubernetes resource, and look for related stuffs, etc. So that's where the connection comes in, right? And invaluable to manage fleet.
Yes. Thanks, Dr. Priya, for the observations.
Sure.
Yes.
I have a
Here has
couple
used
questions.
this? Yeah, Justin, go ahead.
Okay. This is Justin from Policy. So I have two kind of technical questions, which maybe I just need to read through this page. But the collector on the managed cluster, does it sort of just poll periodically for the resources it's interested in collecting, or is it watching for a lot
It
of
is
things?
watching the resources on Kubernetes and reacting pretty much as soon as something changes. We buffer things for a very short period. It's by default it's 5 seconds, just to make the connection and the synchronization more efficient. But pretty much the changes are synchronized near real time.
Cool. And so is that a subset of resources? Like I could specify all the kinds, or
It by default it goes and queries the Kubernetes API and discovers all the resources that are there and start collecting those. We also added configuration where you can configure exactly what you want to watch, because now we found that watching everything in some environments could be a lot of data. So we do provide that configuration where you can limit the things that we collect. But no, we go and discover. So it discovers even custom resources on the Kubernetes API.
cool. And my other question was, how right now are the collectors distributed to the managed clusters? Is it using the add-on framework? Is it something else? And
So
Yeah.
it uses the add-on framework on the ACM product, but like the way the collector gets there, that can be done in many other ways. Pretty much the collector just needs the information of where is the indexer, just like the URL and the authentication. So as long as we have that, we can use any mechanism to put that collector on the managed clusters. Like we do have the add-on framework that does that for us. We are taking advantage of that, but we could use other mechanisms as well.
Right. And the add-on framework is also a part of the open cluster management.
Mhm.
We can use that. And as Jorge said, we were talking about it. I mean, in future, there's probably nobody preventing from this collector being deployed through, let's say, Argo. If we decided to go that route, the only information that the collector needs is the API address where to post data. That's it.
Yeah, we could use other technologies, Argo, we could use Ansible. So it's compatible, just as long as we have the contact information to the indexer in the hub cluster.
Cool, thank you.
Any other questions?
Could you briefly touch on the database requirement? Is there any recommendation on the configuration on database for optimal performance, etc.?
Right now, we are making use of Postgres. So that's what will be default we are trying, but nothing stops us from making it an abstract so that we can support multiple data sources. So we could always bring that advancement. But right now we are making use of Postgres.
And yeah, it could be in very short order. We could also support bring our own Postgres. Obviously, this is a stateful set, Mike, and depending on the data volume, the size will change. And what Xavier, Jorge, and team are currently doing now is they are actually scale testing. And that was one of the reasons why, you can ask, this is an ACM, so why are you bringing it now? This has been ACM for a long time, because we wanted to make it robust to a certain level. So that's why, scale testing is going on this one.
And we're
Uh,
supporting different configurations of Postgres. Now, like our operator will lay down Postgres like in a very basic way, not like even with no persistence or nothing, really lightweight. But like we are also providing configuration where you can add to that and start adding a persistent volume, or like Joydeep said, even configure and bring your own Postgres. So there's flexibility on that. It's just the amount of work and involvement that the user will need in order to scale to different levels. So now it comes with kind of a default. I see it more like as a trial, and then you do put a little more work into updating and providing more features to that database to scale better.
Thank you. I have another question. This is more for the audience. Has anyone used the Search API and want to share their experience with it in terms of maybe in the ACM?
I don't know if Chris Don joined the call. He's our SRE. He does have several cool scenarios where Search has helped him.
Yes. Yes, thank you, Jorge. So yeah, I just want to interject it. As an SRE, we have been running a managed service product in production. And we were able to use Search, basically going through the same flow that Xavier mentioned earlier, allowing us to manage our fleet. And because we had Search, we were able to get alerts from the fleet and then react to those alerts by using Search to help us detect issues. Search basically made all the logs that were being served from the pods accessible at our fingertips, right? All we had to do was put in the right search query to narrow down our search, and we were able to drill into the information that we needed to. So yeah, we definitely did use Search in our managed service operations in a production environment.
Great, thank you.
Yeah, I want to push, I mean, on practicalities, Chris, is it feasible when we are running things in production that you might actually not have a crew config into the cluster where your workload is running, etc.? But
yes.
Yeah.
Yes, exactly. So our particular use case, we did not have the kube config to allow us to directly access the remote cluster, but those clusters were already imported into ACM, and and then searches are of course available, and we were able to leverage Search to gain access to those logs, to those pods, and to those manifests. Even though we did not have a kube config into those clusters. We belong to the SRE team, so our focus is really for the infrastructure. So having this capability was really nice. We did not need to have the kube config directly to have access to those remote clusters.
Right.
Thank you, Chris.
Yeah.
So it really sounds like the Search API project has been battle tested on production environment. And I feel like it seems to be a great addition to the community. So we're hoping the audience and the offline audience to have some feedback for us on the Kubernetes Open Cluster Management Slack channel. Joydeep, what do you think the next step should be regarding onboarding? Yep.
Yeah, I was just going to ask you that. I mean, or talk about that with you. So, I mean, as Jorge and Xavier showed, this is pretty well documented. You can go to our repo, you can download the instructions, will work. You can compile, you can test, the APIs are documented, the architecture is documented. So, Mike, is it appropriate that we open issue requesting an addition put a link to the document and then Slack it to the Coop channel along with this video and ask for opinions? Is that the way we want to go?
Yep, I think that's a great way to gather additional feedback and see if there are any, perhaps any objection to the idea from the community.
Right, right. And one of the big reasons why we are coming here, as Jorge and Xavier touched upon, is we want to go down the route of to find out what's changed, because that's what's really critical. That means storing a little historical data, etc. There are lots of other ideas we have. I am sure community will have tons of ideas. So we want the community to join and move this forward. That's really one of the big goals here, obviously.
Yeah, we're in a situation where our collector has visibility into pretty much everything that's happening in the managed cluster. You know, we want to use that data and bring it up for our benefit.
Yeah, so talking about that a little bit, you heard examples from Chris Doan. He's interested in what the platform is doing. I heard in your example, you know, Jorge, you were talking about pod, and that makes me think more about what the application is doing. You know, the team here has representatives from policy, and they're talking about compliance and audit. So I'm getting the sense that you really feel like this works at a lot of different levels of the stack. Obviously, it's, you know, you take a magnifying glass and you can point it anywhere on that stack, at the platform layer, on an application layer, you know, any policy or any kind of config object as well. Where do you see the biggest opportunities for this project in terms of where do you need the community help? And you mentioned what's changed, you mentioned, you know, AI and some steps in that space, but where do you see the biggest opportunity if somebody does want to jump in here and they want to start, you know, collaborating in that context? What's the starting point in the repo that helps them get there, and where do you feel is the best place to put their energy?
Scott, I personally would think that probably the best place would be around, you know, digging more into what's changed and what should we store in history to make that happen. Because think about it, anytime we get an alert, and Asari gets an alert, or we get an alert, or we are paged or whatever, subconsciously, the first thing we think about is, this was working okay, what's changed, what's screwed up? And what's changed can be a plethora of things. Somebody did a code push, somebody scaled down the cluster, somebody went and changed the deployment replica, maybe the load pattern on the services changed. You know, we were having 100 transactions per second till yesterday, and maybe Scott made a fantastic pitch to the customers or ran an extremely successful promo, and the load has tripled. So it always comes down, and getting the what's changed efficiently is the key thing. There are smart ways to do it. There are unsmart ways to do it. We can say we want all the data in the world and then do it, right? And then back to the other point, I think you touched on an application. We must be careful to show what's changed around what you're querying. Right? If you're querying about a service, several things could have changed, but we want to narrow it down to what is related. And often finding out the relations might not be as simple as we think.
Yeah, so take that example, like it's an application. Are you going to be able to coordinate down to the PR, you know, like who committed this code change, which caused the application to fall over? That's the kind of, like, you'd want to get to the source of where that thing changed. Or was the ServiceNow ticket, which initiated a change of the load balancer, is what caused the platform, which is, you know, Chris Doan's expertise in area. So to me, we need to sort of like embrace these other types of tools where those changes are coming in. And I think that would be where it gets interesting, is how do we start to pinpoint the what's changed into these adjacent tools? Should we also be searching in those tools to be able to provide correlated or related data points to get to the what's changed?
Great point. And I guess that's why there's a white blob called Others Under the Collector. But great point, Scott. I was reminded of some conversation we were having with the Red Hat SRE team that manages the Red Hat clouds. And they were kind of telling that whenever they see a problem, I forget, they look at some of the, they look at a different kind of log on what's happened around the infrastructure, etc. That includes things like somebody made and changed something in the global load balancer, things like that, orthogonal things, which are very important. In lots of cases, if you can get that data in the same page, you know, in a event fashion, you know what went wrong. So you're totally right. Those things are actually critically important, aside from, you know, what's happening in the cluster, maybe key events in the cluster and things like that. But those other things are extremely important. Exactly.
And it gets a little more complex when things happen in a different cluster, and that's where the multi-cluster relationships come into place.
Adding on to Scott's point, right? So where do we need help more, right? So one of the things that I'm thinking is that right now we touched that we only have Kubernetes resources being collected. You know, is there value add in adding events from Kubernetes, right? So how do we store this data, which will make sense in the future for getting insights for, say, processing using machine learning tools. So we want to be able to find out common solutions, which is interesting solutions for everybody. So that's where we need some help on, you know, how to store and manage to get insights from the data that we collected, and what's the different data that we could collect to, you know, tie the knots. So that's something that, you know, we need a lot of help with.
Another area where I'm thinking is, you know, so like I showed the API, it's very developer friendly, but not user friendly. Having a CLI that the end user could do searches would be very beneficial. So that
Great
could
point.
be an independent project.
Hey, I got a quick question. This is Gus. I don't know if it's come up yet, but I'm curious how much data can I search related to secrets?
So the data that search has about the secret is just the name of the secret. That's what we store on the database, name, namespace, and all that. The actual secret, we don't store it. No, we can reference it, we just store the reference to the actual secret, but not the secret. So does that answer the question?
Are you collecting annotations or labels on resources?
We collect labels, not annotations, because that's a lot of data. But labels are kind of a first-class thing that everybody uses to find their resources, and we support those.
Okay, so if I have a certificate expire, I can search and kind of figure out who owns the certificate, but of course I can't see the content.
Yes, I mean, you could use Open Cluster Management to see the content in other ways, not like request that, but like search or what's on the database is just the name of that secret, but you would be able to search for what services are using it. You know, even proactively before the secret expires, you could do a query and find all the deployments that are using that secret and update that before.
Thanks.
Thank you, everyone. Are there any other questions? Joydeep, George, do you want to have any last words before we end the meeting?
Thank you.
Oh.
Thank you, Mike, for allowing us to hop in and present.
So we
Thank
look
you all.
forward to joining the community and contributing our work.
Thank you all. We look forward to your contribution. Take care, everyone.
Thanks.
Thank you.
Bye-bye.